Hello, greetings to you all once again. I'm excited to come your way with another tutorials on calculus, right? And today we are going to talk about the logarithmic differentiation. Are you okay? Yes. So before we even talk about this, please watch the previous video. Try as much as possible to watch them, right? And join the Telegram page. I'll put the link in the description. So once you join the Telegram page, we share questions there which will help students to practice more on anything that we discuss on my channel. You get it? Yes. So try as much as possible to join the Telegram page. And if you've not subscribed try to subscribe to the channel. Right? I want more subscription. That is the only way you can use in paying me. So subscribe to my channel, and at the end, it's a form of saying thank you. You appreciate what I'm doing. Do you get it? Yes. So what is the logarithmic differentiation, right? It is a technique, right? How will I put it, right? The use of logarithm technique, right? So let me see the use of log technique. Let me use log, right? Log technique to perform differentiation. Log technique, right? To perform differentiation. So we can use logarithm to also perform differentiation, and that is what we are going to treat today. Okay, so once we are done, you will see that all what we've talked about in the previous ones, we can also apply the log in differentiating it to get the same answer. But before we move on to the differentiation, let's talk about some log rules. For instance, if I have log a times b, right, it's the same as what? Log a plus log b. This was done in senior high school, so I'm expecting everybody to understand the concept very well. So if I also have log, how do you call it? A on b, right? Then it is the same as what? Log a minus log b, right? And if I have log a exponent, let's say n, I can rewrite this to say it's n log a. I mean, you agree with me? These are things that we did in senior high school. But you see, with differentiation, we don't normally use the log, but we use the natural log. We use the natural log, which is same as the ln. Yes. So we use ln. So assuming I have, let's apply the same rule in breaking down the ln. So if I have the ln of, like, let's say f of x multiplied by what? J of x, then in this case I will say that it's the same as what? Ln f of x, right, plus ln j of x. So you should take note of this. And the same applies to the division. For instance, if I have ln f of x all on what? J of x, then in this case we are going to have ln f of x, right, minus ln j of x. Do you get it? And the last one, if I have ln of, how do you call it, f of x or exponent n, right, then I will say is n ln f of x. Yes, so you need to take note of these log rules. So for instance, if I have the ln of f of x, right, j of x, all on what? Let's say h of x. Yes, I have some complicated expression like this. So assuming I want to break it down, it's the same as what? Ln into brackets f of x, right, j of x minus h of x. minus ln of h of x. So we have minus ln of what? Ln of h of x. Very good. Yes. So I can further break this down, which is going to be what? Ln, for instance, this f of s and g of s can be broken down into two. So we will get ln f of x, right, plus ln g of x, right, minus ln h of x. Very good. So assuming I have ln of what? Ln of f of x, g of x on h of x and q of x. Yes, and I'm supposed to simplify this. What do I get? Let's analyze it. So it's the same as what? Ln of f of x, g of x, right, minus ln of what? Ln of h of x, q of x, right. Yes, very good. But we can still break this down into simpler form. Okay, so we will get ln of f of x, right, plus ln of what? Of g of x, okay, minus, and this will be in a very big bracket. Okay, so minus ln of what? Ln of h of x, right, plus ln of what? Ln of q of x, right. So the negative is affecting both the q of x and the h of x. So this one, if you should further simplify it, that is expanding the brackets, right, you get ln what? Ln f of x plus ln g of x, right, minus ln h of x minus ln q of x. Yes, so this is going to be the simplification, right? If let's say we have a complicated function, okay, so it's just a procedure. You don't need to memorize the results in your mind or memorize it for the exam, right? Just flow with it, understand it. It's natural, right? Let's assume it's natural. Look, it's natural. Just understand the method, and I believe that you'll be fine. But before we proceed, we already know from the log rule that if I should differentiate ln of what? Ln of x, what do I get? I'm going to get, I'll differentiate the s part, which is going to be 1 on x, right? So that is it, right? So differentiating ln x is going to be what? 1 on what? On x. What about differentiating ln 2x? Right, I'll differentiate what is inside, right? So if I should differentiate what is inside, I'm going to get what is 2. So 2 times 1 on what? 2x, right? So this cancels this. Then at the end, what do I get? I'm going to get 1 on what? On x, right? Yes. So if I should differentiate ln 2x squared, what do I get? I'm going to differentiate what is inside, right? So differentiate what is inside, what do I get? I'm going to get 4x multiplied by what? 1 on what? 2x squared, right? So this, one of these s will cancel the x here. 2 goes into itself 1. 2 goes here, how many times? 2, right? So at the end, what do I get? I'm going to get 2 on what? On x. Yes. So you should take notes. That is differentiation of what? Of the ln. So we are going to apply the log technique, right, to differentiate a very complex function. So I'm now stepping into my examples where we will be asked to perform some differentiation. So this is the explanation part. I'm going to solve more examples so that at the end, after watching all the examples, you get the concept to help you go through the differentiation of logarithm. So let's proceed. So let's take example 1. Example 1. We say we should differentiate y equals to what? Ln into brackets 3x, sorry. So ln into brackets what? 3x squared plus 2x minus what? Minus 1. So you say you should find the y on the x. This is very simple. It's one of the simplest differentiation that you can get. When you get something like this, then the y on the x equals, you know what to do. Yes, you differentiate what is within. So we differentiate what is inside, right? So if I should differentiate what is inside, what do I get? I'm going to get 6x, right? 3x squared gives 6x. Then plus what? Plus 2. Are you okay? Then the remainder is going to be what? What is inside becomes a fraction, right? Of 1 on what? On 3x squared plus 2x minus what? Minus 1. Yes. So at the end, we are done. The y on the x, right, equals to what? 6x plus 2 all on what? On 3x squared plus 2x minus 1. Okay, so that is going to be the final result. This is just basic, simple. It's very, very simple. We are going to see more complicated one than this. So let's take example 2. Example 2, right? The question is saying that I should find the y on the x of ln the y on the x, right, of y equal to what? Ln sine 3x, right? Yes. So solution. This is how we solve it. So we know that y equals to what? Ln sine what? Sine 3x. If I should differentiate sine 3x, what do I get? Like differentiating sine 3x, right? I'm going to differentiate what's inside, which is giving me 3. Then the sign will change to what? Cos 3x. Yes. Very good. So that is the differentiation of what? Of sine 3x. So if I should differentiate sine 3x, the results are right there. Are right there first, which is 3 cos 3x. Then what is inside becomes what? A fraction. That is 1 on what? 1 on sine 3x. You get it? Yes. So at the end, the y on the x becomes what? 3 cos 3x all on what? Sine 3x. Okay. But we are not done. We know that 1 on what? On tan x is giving us what? Sorry, not cost. Sorry. So 1 on tan x is cot x. Okay. And if you should look at this very well, it's just the inverse of what? Of tan. Because I know that sine x on what? On cos x, right? Cos x equal to what? Tan x, right? So if I should find the inverse of this, and find the inverse of this, then it means that I'm going to get cos x on what? On sine x equal to what? 1 on what? On tan x. You see? So it's the same thing over here. So in that case, I was just explaining something to you. You don't need to write all this thing when you are solving questions like that. I just want to explain to the layman, someone who have little idea in trigonometry. So at the end, I know that cos x on sine x equal to 1 on tan x. So And we know that 1 on tan x is what? Is cot x. So in that case, this one becomes 3 cot 3x. That becomes the final answer. Are you okay? Yeah, sure. I thank God you are all okay. So let's continue. Let's continue with example 3. This is where I'm going to give you a complicated question. So example 3. Example 3, right? So he says that use the logarithmic, right? The logarithmic differentiation, right? Differentiation to differentiate y equals to what? X plus 1 and x minus 2 all cubed, right? All on what? On x plus 3. Very good. So he said we should use the log approach. So with this case, if you are asked to use the log approach, we find log of both sides. That is the length. We always use the length. So length y should be equal to what? Should be equal to the length of what? Or the function there, which is x plus 1, x minus 2, all cubed, right? All on what? On x plus 3. Very good. So we can split what is at the left hand side, that is this side. We can split it into its simple parts, right? To its simplest form. We can reduce it to the simplest form. So we have length y should be equal to what? I said it's the same as length of what? Of x plus 1. We are using the log rule that we studied just recently, right? That is the first side when we started the video. So x plus 1, x minus 2 cube, right? Minus the length of what? X plus 3. Are you okay? Yes, very good. So we can still split this into separate one or simplest form. We have length y will be equal to what? The length into bracket x plus 1 plus length into bracket what? X minus 2 all cube, right? Minus length into bracket x plus 3. Very good. Now you see this. See this side, right? We can still reduce it because it's exponent of what? 3. So we can still reduce it there. Let's reduce it. And at the end, what do we get? Let me keep on using my blue. You have length y should be equal to what? Length x plus 1, right? Plus 3 length what? Length x minus 2. Very good. Minus length what? X plus 3. Very good. So now we've reduced it to what? To the simplest form. At first they gave us a complicated circle like this one. And we've been able to what? Reduce it to what? To its simplest form. Now let's continue. Now we are going to differentiate. So if I should differentiate this, what do I get? With respect to x. So it's going to be 1 on what? On y, right? It's going to be 1 on y. Because it's respect to x, we are going to get the y on the x. You get it? Yes. So it's 1 on y, the y on the x. You get it? Equal to. And you see, when we are doing the implicit function, I explained to you why we attach the y on the x to it, and why we don't attach the x and the x, because the x and the x will cancel. If you are confused on what I'm saying, it means you've not watched my previous video, and try as much as possible to watch it. You understand why we are having the y and the x, and also we are having no y the x attached to the differentiation of the x. So at this point, I'm going to differentiate what is inside. So if I should differentiate what is inside, that's I'm focusing on this, right? If I should differentiate what's inside, I'm going to get x. So no, 1. Yes, very good. So differentiating x plus 1, I'm going to get 1 times what? Times 1 over what? X plus 1. Are you okay? Very good. Yes. And this side too, plus, if I should differentiate what's inside, I'm going to get 1. I'll multiply with the 3. I'm going to get 3. Right? 3 into bracket what? 1 on what? X minus what? 2. Are you okay? The same applies to this. It's 1 times. We get it? Yes. So, minus, if I should differentiate what is inside here, I'm going to get 1. So, 1 times 1 on what? X plus 3. Very good. So, at this point, we can simplify. We are going to get 1 on what? On y. Y on dx, right? Equals to what? Equals to 1 on what? X plus 1 plus 3 all on what? X minus 2, right? Minus 1 all on what? X plus 3. You get it? Yes. So we can do cross multiplication with the y. We are not done. So the y on the x equals to, we do cross multiplication. That is, we bring the y there. So it's going to be y all into brackets, all into brackets 1 on what? On x plus 1 plus 3 into bracket plus x minus 2, right? Minus 1 into bracket x plus 3. Yes, very good. Yes, but we just want all the variables to be x. So now we knew that y was equal to, from the question, we knew the value of y. Okay, so we just substitute the value of y. So we can say that the y on the x, I'm running x. We can say the y on the x, right, equals to, what was the value for y? Y was x plus 1, x minus 3 all cubed, right? All on what? On x plus 3, right? And it will be multiplied with what? It will be multiplied with 1 on x plus 1, x plus 1, right? Plus 3 on what? X minus 2, right? Minus 1 into bracket of x plus 3. That is going to be the final answer for the differentiation. You are done. This is where you end your solution. You get it. This is the final answer for it. So we found dy on dx. You see, the reason why we need to learn the log is because it is very complicated. And if I should do it, this is quotient rule. If I should apply quotient rule, I need to expand this side and also like find the quotient formula and all that stuff, which is so complicated. So if you are not restricted, I think the log is one of the easiest you can use, right? So if you are not restricted and you get some quotient rule function or something of that sort, you can apply the log rule and you are going to get the same answer. Okay, it's rest assured you can get the same answer. Let's take example 4. Right. Now I'll try to make the video so short. Example 4. Example 4. Right. So we say differentiate y equals to root of what? X minus 2 all cubed, right? All on, let's say, x plus 1 all squared multiplied by 2x minus 1, right? With respect to what? With respect to x, and evaluate the y on the x when x equals to what? 3. This one, product will become very difficult. Someone can use product rule and get the answer. The product rule, we are going to use a lot of like chain rule needs to be there, and a whole lot of stuff. You are going to really struggle. So at this point, I always encourage you to use what? To use the log technique. So with the solution, how do you do it? We know that y equal to what? Root of what? X minus 2 cube, all on what? X plus 1 squared divided 2x minus what? Minus 1. So at this point, what do? We can simplify this even before we continue. I believe you are aware that if I have x squared, some function like this, right, is the same as x 2 over 2, which is the same as x. This cancels this one. Or let me say x, let's say cube, right, is the same as x 3 on 2. Square roots, basically square root is the same as what? 1 half exponent half. That is it. So this one should be part of you anytime as a science student. That square root is the same as exponent half. So if we are supposed to apply that technique in simplifying this, what do we get? We are going to get y equals to, yes, we are going to get y equal to what? X minus 2 exponential 3 on 2. Very good. All on what? On x plus 1 squared and 2x minus 1. Very good. So at this point, let's find the natural log of both sides. Then y should be equal to what? Then, or into brackets, x minus 2 exponential 3 on 2, all on what? X plus 1 squared brackets 2x minus 1. We can still simplify. That's for the left hand side. So we can say that then y is equal to what? The ln of x minus 2 or what? 3 on 2 minus ln of x plus 1 squared multiplied by 2x minus 1. Right. Very good. So we can still simplify. We have then y equal to what? 3 on 2 ln of what? X minus 2. Right. Minus, let me put this into brackets. So we have ln of what? X plus 1 squared plus ln of what? 2x minus 1. Right. We can still simplify this, and we are going to get then y equals to what? 3 on 2 ln x minus 2, right, minus this one will come down, which will give us 2 ln what? Then x plus 1, right, yes, minus ln 2x minus 1. Very good. So now we've been able to break it down to the simplest form. So now let's differentiate. Now differentiating, we are going to get 1 on what? On y, y on the x, right, equals to, if I differentiate what is inside, I'm going to get 1. So 1 multiply with 3 on 2 is going to give me the same as 3 on 2, right? We are going to get 3 on 2. I differentiated what's inside, and differentiating it, I'll get 1. I multiply the 1 with 3 on 2. I'm going to get 3 on 2. Multiply by what? 1 on what is inside, which is x minus 2, right? We are done with the first one, minus the second term. We are differentiating what is inside here. We are going to get 1. 1 multiply with 2, going to give us 2, into bracket 1 on what? X plus 1. Very good. Then minus, differentiate what's inside here. What do we get? We are going to get 2, right? going to be 2 multiplied by what? 1 on what? On 2x minus 1. Very good. So when you get to this level, I will encourage you to take your time. If you don't take your time, you end up making a lot of mistakes. So you take your time and you do it well. But once you get the results, you quickly move to the next step. So let's move on. You are going to get 1 on y, dy on dx equals 3 on what? On 2 into brackets x minus 2, right? Minus 2 on what? X plus 1, right? Minus 2 on 2x minus 1. Very good. So we bring the y to that side of the equation. We bring the y to that side of the equation. And how do you bring the y there? So the y gets to this side. So at the end, what do I get? I'm going to get dy on dx on what? Dx. Sorry, dy dx, right? is equal to y into brackets 3 on what? 2 bracket x minus 2 minus 2 on what? X plus 1 minus 2 on what? 2x minus 1. Actually, mathematics drain a lot. If you are solving mathematics, it drains a lot of energy. So you need more energy to solve mathematics. So let's continue. That was just by the way. So I have dy on what? On the x equals to, what was the value for y? We know that in the question, y was given as this. So this was y in the question. We just substitute that into the expression. Okay. So we can substitute that to expression to get our final answer. So dy on dx is given as, sorry. So dy on dx can be given as, let me look at the y value again. Yes, I've got it. So dy on dx is given as what? Roots of what? X minus 2 all squared all cubed. Yes. On what? On x plus 1 squared all on what? Another 2x minus 1 hierarchy. Then multiplied with what? It's multiplied with 3 on 2x minus 2 minus 2 on what? On x plus 1 minus 2 on what? 2x minus 1. Right, very good. So that's if the result is just the result, the differentiation. But you see, in the question, they stated that x is equal to what? Is equal to 3. We are now going to substitute the value of x. That is, we find dy dx when x is equal to 3. So dy on dx equals to what? Root of, put the 3 there. 3 minus 2 minus 2 all cubed, right? On 3, wherever you see x, put 3 there. So 3 plus what? Plus 1 all squared, right? And we have 2 times 3, right? Minus 2 times 3 minus 1, right? Then multiplied by what? 3 on 2 into bracket 3 minus 2, 3 minus 2 minus 2, very good, minus 2 all on 3 plus 2, 3 plus 1, sorry. So 3 plus 1. Then the last one minus 2 bracket of 2 multiplied by 2x, 3, right, minus 1, minus 1. Yes. Wherever you see x, you place the 3 there. So now we can simplify. We again get square root of what? 1 cube, right? All on 4 squared, right? Yes. 4 squared minus times 5, right? If I should simplify what's there, it's going to be times 5. So 4 squared times 5, right? 6 minus 1 is 5. All multiplied by what? 3 on 2 minus 2 on what? On 4 minus 2 on what? On 5. Very good. So let's further simplify. We are going to get 1 on what? On 80. This is 16. 4 squared is 16 times 5 is 8. Yes, very good. We are going to get 80 there. It's going to be 1 on 80. All multiplied by what? 3 times. I'm finding the equivalent fraction. So I just multiply here by, I'll multiply this side by what? By 10. All divided by 2 times 10. What I'll do is, because all is 20, right? Because all is 20, I just find the equivalent fraction here. To find the equivalent fraction, I just multiply here by 10, here by what? 10. Then this side to I want 20, so I'll multiply this by 5, this by 5. Now multiply this by 4, this side by 4. So the denominator, all of them will be 20, 20, 20. Very good. So I'm going to get 30 on what? On 20 minus what? Then on what? On 20 minus 8 on 20. Very good. So what do I get now? I can further simplify. So with further simplification, I'm going to get 1 on 80 all on what? 30 minus 10 is going to give me 20, right? And 20 minus 8 should give me 12. I'm going to get 12 on 20. You get this. So now we can further simplify. So what do we get? 4 goes here, 3. 4 goes here, 20. Yes. So at the end, I'm going to get 3 on 400 as the final answer. We have simplified when x is equal to 3. So you watch again and you understand. Okay. This time I'm pausing small. I've really been drained, right? I'm pausing. I'm going for a break. So I'll pause and I'll make sure that I'll continue. Right. All the best. Hello and welcome back from the break. Right. But this point, if you've not subscribed to my channel, please subscribe to it. Right. I'm pleading with you. Please subscribe to it. And it's a form of saying thank you. Right. And join the Telegram page as well. On the Telegram page, I'll try to upload more questions, share more questions with you that you solve. The goal here is to make sure that you get 80 plus in calculus. Yes. So anyone who have been following me diligently should not get anything less than 80. Once you get something less than 80, I'll be really disappointed because I've sacrificed a lot of time in making sure that you understand calculus. Okay, so let's solve example 5. If I'm not mistaken, we have example 5 here. And with the example 5, right, it's saying that given that y equals what? 3 e 2 theta sec 2 theta, all on what? On square root of theta minus 2, right? If you determine dy theta. So you should determine this one. So this one can be rewritten. Okay, you can write it again because we know that sec. Let me write it so that you understand. So we have y will be equal to what? 3 e 2 theta on root of what? On theta minus 2 times sec 2 theta. Yeah, we've not change in it. We just separated the sec 2 theta from the whole expression, because we know that sec x is equal to what? 1 on what? Cos x. So we want to change this sec x to 1 on cos x. That is, y can be equal to what? 3e 2 theta, all on what? On square root of what? Theta minus 2 times 1 on what? On cos 2 theta. Yes. Take note. We can also split this side too by saying that y is equal to, we can now multiply the square root of 2 minus theta minus 2 with what? Cos 2 theta. So we are going to get 3e 2 theta, all on what? On theta minus 2. We know that it's exponential half. I made it clear to you that root of x is equal to what? X half. So it's the same as theta minus 2 half cos 2 theta. Very good. Please take note. You can skip these steps if you are very smart, right? And you know you don't make any mistake. You can choose to move right from here to this side, without writing this one. So yes, you should always take note of it. So now that we've gotten this, you can find the length. We've been able to reduce the expression to something that is clearer. So now that we've been able to do that, we can find the length of both sides. So length y, before we even differentiate length y, we can split this one also into their simplest form. So let's do that. We can see that length y is equal to what? Length bracket 3e 2 theta. Very good. Then minus length of what? Length of theta minus 2 half cos 2 theta. Right. Very good. Yes. Now you can also break this and this, or the two of them. That is the first term of the left hand side and the second term of the left hand side. You can break it down to their simplest form again. And if you are doing that, we will see that we have length y is equal to what? Equals to length 3 plus length what? Length e 2 theta. Very good. Minus, the minus affected with all of them. We will minus into brackets length theta minus 2 half, right, plus length cos 2 theta. Right. Very good. Yes. So this is brackets. You should take it. This side is a bracket. So it's a bracket. Bracket of the length. Very good. Very good. Very good. So we can say that then y. Let's try to bring this one down. We can say then y equals to what? Length 3 2 theta. Right, down. So it's going to be plus 2 theta length e. And let's expand the bracket as well. 2 theta length e minus, this is half, right? So it's going to be half length theta minus 2. Very good. Expand the bracket. So this negative will be negated. It will affect the positive here. It's going to be minus length into bracket what? Cos 2 theta. Very good. Yes. So at this point, we can still simplify something. See, length e. This length e and this 1. That is the rule. If I should simplify, if you pick your calculator, you can enter. Length of e is 1. So we will get length y is equal to what? Length of the constant plus 2 theta minus half length what? Theta minus 2, right, minus length into bracket what? Cos 2 theta. Very good. Very, very, very good. We are almost there. Now it has become so simple for us to what? Differentiate. Right? If I'm differentiating on y, I'm going to get 1 on what? On y. And because it is with respect to theta, this will be what? dy on what? On the theta. Are you okay? Yes. Equals length of a constant is 0. Differentiating any constant becomes 0. Right? When you are differentiating any constant, it will be 0. Plus, and this is going to give us what? 2. Right? 2 minus, if you are differentiating this, you differentiate what is inside here. So, theta minus 2, differentiating theta minus 2 will give us 1. Then we multiply it with a constant which is outside. That is half. So, 1 multiplied by half will still give us half. Right? All into brackets 1 on what? On theta minus 2. Very good. Very good. Yes. Minus. Okay, what happens here? I'm going to differentiate cos 2 theta. So differentiating cos 2 theta, we are going to get 2 minus 2. Yes, the sign is always negative. When we are differentiating from cos to sine, we get minus. So at the end, we are going to get differentiate what's inside first. What's inside? And that is 2. Right. Our sign is always negative. So let's put the negative there. Minus 2, right? Sine. You get it? Sine 2t. 2 theta. Very good. So you differentiated the cos inside. So it's 2 sine 2 theta. And it's negative. Right? Multiply by what? Multiply by 1 on what? On cos 2 theta. Very good. So that's it. That's it. We differentiate what is inside, then it will be 1 over what is inside. Yes, this is quite challenging. So anytime you are solving it, please take your time. When you get to something like this, take your time and do it very well so that you get the right answer. Okay, so at this point, 1 on what? Y dy on the theta equals, let's take off the 0. So it's going to be 2. 2 minus 1 on what? On 2 to bracket theta minus 2. Very good. Plus this negative plus 2 sine 2 theta all on what? Cos 2 theta. Very good. So now what do we get? We are going to get 1 over y dy on the theta, right, equals 2 minus 1 on what? On 2 theta minus 2 plus 2 tan sine and cos becomes tan 2 theta. Very good. Okay, so now we can proceed. Now we will bring the y to this side, cross multiplication. We are going to get dy on the theta equals y into brackets 2 minus what? 1 on what? On 2 into bracket theta minus 2 plus 2 tan 2 theta. Right. Very good, very good, very good. I think we are on track. Yes. So what is the value for the y? The y is giving us this in the question. The y is giving us 3e 2 theta sec 2 theta all on what? On square root of 2 theta. So you are going to replace that 1 with the y. So dy on the x should be equal to what? Dy on the theta, sorry. Dy on the theta is equal to 3e 2 theta sec 2 theta, right? All on what? On square root of theta minus 2, right? Times multiplied by 2 minus 1 on what? On 2 into brackets theta minus 2. Very good. Let me write it off. So 2 into bracket theta minus 2, right, plus 2 tan 2 theta. I think once you do this, you are good to go. Now, the solution has been achieved. Okay, so this is the solution of it. So if you are using the product rule, you solve and solve and solve and solve, and you might be confused. So please, when you are doing something like this, take your time. Okay, and I believe that you get there. Let's solve one last question. Then we'll bring the lectures to a close. So it says differentiate y equals x cubed, then what? Then 2x, right? All on what? On x sine x. Wow. This is quite complicated. True or false? Yes, true. But let's solve it. Let's solve it using the lane derivative or lane differentiation, the lane technique. Any of them, you are right to go. Okay, so let's continue. So we have y equals to what? X cubed, then what? Then 2x all divided by what? X sine x. Right. So I'll find lane of both sides. This one, can you split? No, I think the way it is fine. We don't need to simplify the expression. So the way it is fine. We can just go our way to find the lane of both sides. Yes. We can find the lane of both sides. But before we even apply the differentiation, we can simplify the left hand side. So we have then y should be equal to what? The lane of the numerator, which is s cubed, then what? Then 2x, right? Minus the lane of what? Of ex sine what? Sine x. Very good. Very good. I always love to put the angle of the sine in the brackets. Some people don't do that. Like this one over here. You see, I didn't put it inside. That's how it was written in the book. But I prefer always putting my sign in the bracket. That to be so correct. So at this point, I can still simplify what is at the left hand side. So we can say that then y is equal to what? Then x cubed, right? Plus lane of lane. Hey, lane of lane. Wonderful. Lane of lane 2x, right? Minus or into bracket lane ex sine plus lane of what? Sine x. Very good. So let me put this in the bracket, and also we have a big bracket over here. Yes. So that is it. If I should split, what we are doing here is that if I just split this one into two, you see that there are two functions. So I have the s cubed over there, then plus the lane of the lane 2x, right? Minus lane of ex over here. But this one too, we can split it to two. So lane of ex plus lane of what? Of the sine x. I think we are right. So let's continue. So at this point, I'm going to eradicate the exponent by bringing it down to what? To the front of lane x. That's the coefficient of lane x. So I will say that then y should be equal to what? 3 lane x. Right. Don't put this in brackets. Plus lane. This one we have no exponents. And differentiating this will be quite challenging, but we will do it. Lane bracket lane 2x, right? Minus x lane e, right? Minus ln sine x. Very good. Yes, because the negative here positive. The negative will overwrite the positive. Yes, I'm trying to dodge the ln, but I'll still meet it. See, we can differentiate this side, right? Is 1. Okay. So we will say that ln y is equal to what? 3 ln x plus ln into bracket. Let me use a different ink so that it will be clearer to me. Yes, ln into bracket ln 2x, right? Very good. Okay. Minus x minus ln what? Sine x. Very good. So now we are going to differentiate. But first of all, let me differentiate this. 1 on what? On y, dy on dx. Very good. So we are differentiating with respect to x. So it's going to be 1 on y, dy on dx equals to this one. Then x is going to be 1 over x. So it's going to be 3 on what? On x. Okay. Then plus, let's differentiate this. What I was dodging have finally come to my way. So let's continue. If you are differentiating this, right, I'll differentiate what is inside. So this is the big one. This is the big lane. So I'm going to differentiate the lane inside. Okay, so what is lane 2x? If I should differentiate lane 2x, what do I get? I'm going to differentiate what is inside the core one, which is 2. Okay. Then it's going to be 1 on x. That is 1 on 2x. That is differentiating this whole lane. The lane inside here gives me 2 into bracket 1 on 2x. Right. And now we write the whole lane again. Multiply by 1 on what? On lane 2x. I mean, you are getting. We are differentiating the big one, the big lane. That's what you are differentiating. We differentiate what is inside. Then we multiply it with the fraction of it. Always, when we are differentiating lane x, right? We say we differentiate what is inside, which is 1. Then we multiply with what's the fraction of it. Okay. So the same way too, we differentiate what is inside. And if I should differentiate what is inside here, I'm going to get 2, 1 on 2x. So I've differentiated what is inside. Then I rewrite it again, which is 1 on what? Lane 2x. So that's it. But this cancels the 2, cancels the 2. You remember when we were doing our first video, the first video, that's before the break, right? We differentiated lane 2x and we had 1 over x. Yes, and it has repeated itself here. So at the end, I'm going to get 1 over x, right? Very good. So let's maintain this one like this. In the next step, we'll rewrite it more. So minus, let's continue. So this one becomes 1. If I'm differentiating s, I'm going to get 1. Then I'm going to differentiate sine x, which will give me what? Cos x, right? Multiply by 1 on what? On sine x. Very good. Very good. Very good. I'm on point. Challenging, right? To be well. Just prepare, Ayuki. 1 over y dy on dx equals to what? 3 on what? On x. Plus, we had 1 on x. Okay, so let's write it like 1 on x multiplied by what? 1 on what? On lane 2x. Very good, very good, very good. I'm on track. Yes. Minus 1, right? Minus cos x on what? On sine x. Very good. Very good, very good, very good, very good. So at this point we can simplify it. But you remember that cos x over sine s is cot. It's cot s. I think we did it in this video. Yes. So cos s over sine s is cot. we are going to have 1 on y, the y on the x, right, equals to what? 3 on what? On x plus 1 on what? X, then what? Then 2x minus 1 minus what? Cot x. Do you get it? Yes. So now, let's put all this into brackets because we are going to move the y cross multiplication to this side. So at the end, we are going to get the y on the x equals to what? Y into bracket what? 3 over x plus 1 on what? On x, then 2x, right? Minus 1 minus cot x. Do you get it? Yes, very good. Now, what was the value for y? What was the value for y? Y was given us what? Y was given us x cubed then 2x on what? On ex sine x. We are going to substitute the y value there. Then we end the what? The tax. So the y dx equals what? Because x cubed then x all on what? On ex sine x. Am I on track? Did I write the same? Yes, I did. Did I? No. Okay, I passed. It was 2x, sorry. It was 2x. So this is 2, right? This is 2x, not x. So 2x, right? Multiply by what? 3 on x. 3 on x plus 1 on what? On x, then 2x, right? Minus 1 minus cot x. You see, this, what I'm doing over here, I'm doing it on a purpose too, right? Probably maybe I'm not a lecturer and in the near future someone might want to see how I teach. Okay, so I don't like editing my videos too much, so that I'll put the raw video there. At the end, student will watch it. After doing the tutorials, I go over again, but I rush through. I don't take my time to watch everything. I rush through to see whether I have made some mistake. So maybe if, let's say, you come across any error, right, you can address it and tell me the section where the error is. And if I made a mistake, I will inform you. But if it is not a mistake, then the student is not understanding it, I'll try to rather explain. Okay. So I don't like editing my video too much, because if I edit it, it will be more like I'm not showing the raw part of it, and at the end, you're going to distract the plan. Although I'm teaching you, but it's also for a purpose. In the near future, yeah, someone might come here, or let's say someone who wants to see how I teach, might come here to watch the video. And once he sees it, he knows that oh, this is a raw video. There was no editing or any other stuff. Okay, yes. So if you see any mistake, please try to alert me. I'll correct it. Thank you very much. And please try as much as possible to subscribe to my channel. This is the solution. This is the final solution of what we saw. So this is the solution of it. So thank you very much, and please subscribe. Please subscribe, right? Please subscribe to my channel. And join the Telegram page. I wish you the best of luck in your studies. All the best. Bye.